toxicity issues. Government health agencies are concerned about boron toxicity. But first, let's look at the toxicity of table salt, also known as sodium chloride. Acute oral toxicity, LD50, the dose at which half of the tested animals die. 3,000 mg of table salt per kg of weight, rat. Chronic effects on humans, mutagenic for mammalian somatic cells. Slightly hazardous in case of skin contact, ingestion or inhalation. Lowest published lethal oral dose in man? 1,000 mg per kg of weight. Causes adverse reproductive effects in humans, fetotoxicity, abortion, by intraplacental route, may increase risk of toxemia at pregnancy in susceptible women. May cause adverse reproductive effects and birth defects in animals, particularly rats and mice, fetotoxicity, abortion, musculoskeletal abnormalities, and maternal effects on ovaries, fallopian tubes. May affect genetic material, mutagenic. Ingestion of large quantities can irritate the stomach with nausea and vomiting. May affect behavior, muscle spasticity, contraction, somnolence, sense organs, metabolism, and cardiovascular system. Continued exposure may produce dehydration, internal organ congestion, and a coma. Now, compare the table salt toxicity with the material safety data sheet or MSDS for borax. Low acute oral toxicity, LD50 in rats, 4,500 to 6,000 mg of borax per kg of body weight. Reproductive, developmental toxicity, animal feeding studies in rat, mouse and dog, at high doses, have demonstrated effects on fertility and testes. Studies with boric acid in the rat, mouse and rabbit, at high doses, demonstrate developmental effects on the fetus, including fetal weight loss and minor skeletal variations. The doses administered were many times in excess of those to which humans would normally be exposed. No evidence of carcinogenicity in mice. No mutagenic activity was observed in a battery of short-term mutagenicity assays. Human epidemiological studies show no increase in pulmonary disease in occupational populations with chronic exposures to borate dust, and no effect on fertility. Here you see that table salt is 50 to 100% more toxic than borax. It changes the genetic material and is mutagenic, while borax is harmless in this regard. Infants are most at risk from high borax ingestion. It has been estimated that 5 to 10 grams can cause severe vomiting, diarrhea, shock and even death, but it also says that lethal doses are not well documented in the literature. The following toxicity data are from documents of the U.S. Environmental Protection Agency and the Centers for Disease Control. A review of 784 accidental human poisonings from 10 to 88 grams of boric acid reported no fatalities, with 88% of cases being asymptomatic, meaning they did not notice anything. However, gastrointestinal, cardiovascular, hepatic, renal, and central nervous system effects, dermatitis, erythema, and death have occasionally been observed in some infants, children and adults exposed to more than 84 mg of boron per kg of body weight, corresponding to more than 40 grams of borax for 60 kg of body weight. Animal studies have identified reproductive toxicity as the most sensitive effects of boron ingestion. Exposure of rats, mice, and dogs for several weeks showed some damage to the testes and sperm at doses of more than 26 mg of boron per kg of body weight, which corresponds to 15 grams of borax per day for someone who had 60 kg of body weight. Most at risk is the developing fetus, and in the studied animals, rats were most affected. In one study, slight reductions in the fetal body weight were already found at 13.7 mg of boron per kg of weight each day used during pregnancy. The no-effect dose during pregnancy was set at less than 13.7 mg of boron per kg of body weight each day, corresponding to about 7 grams of borax per day for someone who had 60 kilograms of body weight. With an added safety factor, a no-effect value of 9.6 milligrams of boron per kg of weight each day was calculated, corresponding to 5 grams of borax for someone who had 60 kilograms of body weight. However, a rat study lasting for 3 generations found no reproductive toxicity or effect on the parents or offspring at 30 milligrams of boron per kg of weight each day. This dose corresponds to 17 grams of borax for 60 kilograms ingested for 3 generations. In another 3-generation study, no problem was found at 17.5 milligrams boron per kg of weight each day, corresponding to 9 grams of borax for 60 kilograms, while the next higher tested borax dose of 58.5 milligrams per kg of weight each day, corresponding to 30 grams of borax for 60 kilograms, resulted in infertility. Therefore we can assume that the safe reproductive dose is about 20 grams per day for someone who weighs 60 kilograms. Human studies of the possible association between impaired fertility and high boron levels in water, soil and dust in Turkish populations, and boron mining and processing workers, found no effect. One study even reported elevated fertility rates in borax production workers as compared to the US national average. All this is important because possible reproductive toxicity is the official reason for the present assault on borax. The sodium chloride MSDS mentioned above also states, quote, "While sodium chloride has been used as a negative control in some reproductive studies, it has also been used as an example that almost any chemical can cause birth defects in experimental animals if studied under the right conditions." Unquote. Keep this in mind for the next video.